Alright guys, welcome to Michsurd Academy. So today we are going to be looking at measurement in physics. Alright, so my name is Akabogifa Mike. I am very excited today because this is the first video the Michsurd Academy is making. Okay, so I would really love you to click on the subscription button. It does not cost you anything. Okay, it does not cost you any money. It's totally free. So as to get updated with our series of videos that will be coming up in maths, physics, and chemistry. Alright, so in measurement is a very important concept in physics. Okay, because virtually everything we do in physics have to do with what? Measurement. Okay, you say you want to take the distance from point A to B, you are doing what? Measurement. You want to take the time travel from point A to B, you're also taking what? Measurement. You want to take the weight of an object, you're also doing what? Measurement. So you see, almost everything we do have to do with what? Measurement. Alright, so when you talk about measurement, of course, what comes to your mind is calculations. Okay, do more of calculations. But yet, measurement is one side of the coin. Okay, because we have what we call the measurement analysis and we have the error what? Analysis. Now, the error analysis is as a result of the faultiness in our what? In our measurement. So sometimes we tend to make some mistakes while calculating or making our measurement. So this results to what we call what? Errors. Are we together? Alright. So now, what we are going to focus on is measurement analysis. So in our practical physics course, we are going to look at error analysis. Okay, are we together? Alright. So now, measurement, when you talk about measurements, what comes to your mind also is what are the things we measure? What are the things we measure? Okay, those things we measure are called what? Quantities. Or you say quantities. So when we take measurements, we take measurement of different what? Quantities. Okay. So now in quantities we have what we call the fundamental quantities and we have what we call the derived quantities. So we have the fundamental quantities and we have the what? Derived quantities. So these are the two types of what? Quantities that we have in physics. Now let's go later we still discuss about the fundamental and the derived quantity. Let's look at this scenario. Someone said that please give me 5. You ask the person what's 5. Why? Because this 5 is not properly what? Defined. You understand that? It does not make any sense. It's surprising to say give me 5. 5 words. Okay, but when you look at this, if the person says give me $5, wow, you quickly know what the person is what? Asking for. Why? Because of this 5 is what? Is well defined with the what? With the dollars. You understand that? It can be 5 naira or so, but the main point is that the 5 is properly what? Defined. So the same thing happens in physics. When we talk about quantities, we talk about what? Their units. Okay? So the unit defines the quantity properly. Are we together? The unit defines the quantity what? Properly. Alright. So now we are going to look at some examples of the fundamental quantities and also some examples of the derived quantities and their units also. Okay. Now, but I want to make this clear. There are some quantities that do not have units. Such quantities we refer them as what? Dimensionless what? Quantity. So later on in the course you are going to see what we mean by these dimensionless quantities. Okay. Alright, so I'll wipe this part of the board so that we can go to the examples of these quantities. So we look at the examples of the fundamental quantities and their units. Okay. All right. So let's say this part of it is the fundamental quantities, and this part of it is the fundamental units. So number one example we are going to take is the length. It has a unit called meter, abbreviated as small letter m. Okay. Then we have mass, which has a unit of kilogram, which is in kg, abbreviated as kg. Then we have time, which has its units to be in seconds, abbreviated as what? X. We also have, we just take 4 of 8, we have temperature, which has its units to be in Kelvin, abbreviated as what? As K. Okay, so we have so many of them, your current and so on. Okay, so now if you watch, these are the fundamental units for their respective quantities. Okay, now if you look at this meter, we have kilogram, we have seconds, and we have Kelvin. This meter here is not the only unit for what? For length. We can have other units like your centimeter for length, millimeter for length. Also, apart from kilogram, you can have gram, milligram, okay, and so on. Then apart from seconds, you can have minutes, or even what? Hours. Okay. Then your Kelvin, you can have your Celsius, you can have your what? Your Fahrenheit for temperature instead of Kelvin. Now, why are we using these ones here? Okay, we use these ones because of what we call the SI units. So these are the SI units of these different quantities. The SI unit is the system international unit, okay, or the standard international unit, the unit that is widely accepted. Okay, so we call them the SI units. Alright, so now we are going to go to the examples of the derived quantities. So we have examples of the derived quantities. Okay, so I'll write the derived quantities here. Then I'll write the derived units here. Alright, so number one example we take is area. Area is given as meter square. That's the units for area. Okay, we have volume is another derived quantity. It is given as meter cube. We have density. It is given as kilogram per meter cube, or you can still write it as kilogram per meter cube in form of indices. Then we have velocity. Velocity is given as meter per second, or you can still write it as meter per second. Okay, now we have acceleration as another example of derived quantity. It can be given as meter per second square, or you can have it as meter per second square. Still the same thing also. Then we have force. Force is given as kilogram per meter square. Okay, but we have a general name, we call it, we use the unit as what? As Newton. So in most calculations, you will not see kilogram meter per second square for force. Instead, you are going to see what? Newton, which is abbreviated as capital what? N. So if I say give me 12 Newton, of course, you know that I'm talking about what? Force. All right. So let's take another one. We have for pressure. Pressure is given as kilogram per meter per second what square, which we call everything here Pascal. Maybe because it's too long or we don't want to be calling these different quantities, we call them just what? Pascal. Okay. So we use PA to abbreviate for what? For Pascal. So these are some of the derived quantities. We have so many of them. Okay. But these are the ones that I can list out for us now. Some of the derived quantities are this. So now if you watch closely, they are called the derived quantities because they are gotten from the combination of two or more words